Hello and welcome to the second episode of the Nameless Show. I am your humble narrator, the Madman, and today we're going to be looking at part 2 of our flat domed closed system explained by D Murphy 25 and posted by Eric Bowser 111. So if you watched the first episode, you know we talked about gyroscopes and magic water. Well, in this episode, we're going to talk about Bedford levels and magic air. But before we take another look at this video, I want to give a quick shout out to all the great people in the Spherical Earth Society group on Facebook. I enjoyed immensely all my time on there, and I'm so happy I joined. And they're just a great group of people. I appreciate all of you. I have to say the best part about this video is that the footage that they have provided just does an elegant job of proving that the Earth is round. So I have to thank the folks who produced the Flat Earth videos once again for including the footage we need to debunk you. And so we'll be going to a few alternate sources, but mostly we'll be sticking with the video. So let's see what they have to say.
The thing is, what the scientists will give you is calculations and and theories.
Yeah, those scientists and their calculations and their accurate predictions and their lab coats.
Why that happens, but we have experience. We see.
Oh, this is just beautiful. Thank you again. All the folks who produce these flat Earth videos, just an excellent shot of the curvature of round Earth, and we thank you for that. There's just it's always rewarding to know that no matter what picture you use in the video you're trying to make to prove the Earth is flat, it's always round.
Things, and they either make sense or they don't make sense. What the scientists do is substitute our common sense and our intuition for calculations and theory. And we're
Okay, so speaking of our senses, how much can we trust them? Well, there's a whole class of images that are called optical illusions, but really there's nothing wrong with the pictures. It's the way our brains process them. This one and this one were like moving all over while I was looking at this page. It was weird. Anyway, our eyes don't interpret everything correctly. That's just the bottom line. That's an interesting one there. This one is a frog, right? But it's also the head of a horse. So there's the head of the frog, back of the frog, legs of the frog, but also there are the eyes of the horse, the nostrils of the horse, the ridge for its other eye, the ear, the mane. And so if you ever wonder why people maybe are in the woods and it's at dusk and they see a bear in motion, it might look like something different entirely. That's a classic one. All those lines are the same length, even though for most people they look like they're different lengths. And since we're going to be talking about images of, objects on the water, here's an interesting one. How light bends when it hits water. So light coming through the air hits a denser medium and is bent in one direction. So comes down, hits her head, is bent backwards, and then continues along in the same path. So, see how that works? It makes it appear as if her head is entirely disconnected from her body. Interesting effect, caused entirely by, just like I said, light traveling through air and hitting a denser medium.
supposed to believe the calculations rather than what we experience.
Sometimes what we experience is not what is real. That's why scientists use instruments when they do experiments and stuff like that. They don't always trust their eyes. They have sensitive instruments to make sure.
Ourselves. There was a famous experiment back in the 1800s in England called the Bedford Levels experiment. Now, the Bedford Levels is a canal that is perfectly straight for 6 miles. Okay, so what a chap called Samuel Rowbottom did was he took a telescope, put it in the water about 8 inches above the water, and he had a friend, in a rowboat with a flag on the back, row all the way to the other end, and he was able to see the flag on the back of the rowboat the whole distance.
All right, so researching this video was an excellent opportunity for me to learn about the Bedford Level experiment. Okay, so this was an interesting opportunity to read up on the Bedford Level experiment, which is a series of observations carried out along a 6-mile or 9.7-kilometer length of the Old Bedford River on the Bedford Level, Norfolk, England, United Kingdom, during the 19th and early 20th centuries to measure the curvature of the Earth. Samuel Burley Rowbottom, who the same gentleman, the guy in the video was just talking about, who conducted the first observations starting in 1838, claimed he had proven the Earth to be flat. However, in 1870, after adjusting Rowbottom's method to avoid the effects of atmospheric refraction, Alfred Russel Wallace found a curvature consistent with a spherical Earth. Alfred Russel Wallace. All right. So, how did this all go down? The first experiment at this site was conducted by Rowbottom in the summer of 1838. He waded into the river and used a telescope held 8 inches above the water to watch a boat with a flag on its mast 3 feet or 0.91 meters above the water row slowly away from him. He reported that the vessel remained constantly in his view for the full 6 miles or 9.7 kilometers to Welney Bridge, whereas had the water surface been curved with the accepted circumference of a spherical Earth, the top of the mast should have been some 11 feet or 3.4 meters below his line of sight. He published this observation using the pseudonym Parallax in 1849 and subsequently expanded it into a book, Earth Not a Globe, published in 1865. Rowbottom repeated his experiments several times over the years, but his claims received little attention until in 1870, a supporter by the name of John Hampton offered a wager that he could show, by repeating Rowbottom's experiment, that the Earth was flat. At that time, noted naturalist, qualified surveyor, and one of the great pimps in the history of science, Alfred Russel Wallace, accepted the wager. Wallace, by virtue of his surveyor's training and knowledge of physics, avoided the errors of the preceding experiments and won the bet. The crucial steps were, first, to set a line of sight 13 feet or 4 meters above the water, and thereby reduce the effects of atmospheric refraction, and second, add a pole in the middle that could be used to see the bump caused by the curvature of the Earth between the two endpoints. Despite Hampton initially refusing to accept the demonstration, Wallace was awarded the bet by the referee, editor of the Field Sports magazine. Hampton subsequently published a pamphlet alleging that Wallace had cheated and sued for his money. Several protracted court cases ensued, with the result that Hampton was imprisoned for threatening to kill Wallace and for libel. The same court ruled that the wager had been invalid because Hampton retracted the bet and required that Wallace return the money to Hampton. Wallace, who had been unaware of Rowbottom's earlier experiments, was criticized by his peers for his injudicious involvement in a bet to decide the most fundamental and established of scientific facts. In 1901, Henry Ewell Oldham, a geography reader at King's College, Cambridge, reproduced Wallace's results using 3 poles fixed at equal height above water level. When viewed through a theodolite, a precision instrument for measuring angles, the middle pole was found to be almost 3 feet higher than the poles at each end. This version of the experiment was taught in schools until photographs of the Earth from space became available. So who was Alfred Russel Wallace? Well, a really impressive scientist, actually. Among other things, he co-conceived evolution by natural selection and had his work published with Charles Darwin in 1858. But he was also the guy who, when John Hampton said, "I think the Earth is flat and I've got money," said, "I'll take that bet, sir, right this way." Great science pimp of history. And fair warning, over the next few scenes, I may come completely unhinged and use the C word a lot.
Now, according to spherical trigonometry, the curve of the Earth is 8 inches per mile squared. So over 5 miles, that's 5 times 5, 25, times 8, which is 200, works out, that's 200 inches, which works out at 16 feet. That means the boat should have been 16 feet below the horizon.
And video going downhill in 3.
He shouldn't have been able to see the boat.
1.
Now, the scientists will say, oh, refraction and this and light bending around the Earth and...
I don't know what to love more about this. The fact that we go straight from a scene of a flat Earth guy chuckling about the idea of atmospheric refraction causing weird stuff to be seen directly into a video of weird stuff. In this case, the mirage of a bridge and the vehicles going across it. Another great thing about this picture is you can see the curvature of the Earth in it.
Stuff.
Just like all these pictures.
But the fact is,
curvature. That's the fact is curvature. Good times. And we're going to find that that is true in all of these pictures. In every single one of them, really, you can detect. It's not flat, folks. And I mean, I don't just mean it's not level, which it isn't.
it's perfect.
Oh, here we go with perfectly flat again. Not perfectly flat. I'm not looking at a perfectly flat surface, folks. I don't know about you. And I ain't talking about the bridge either. I'm talking about the water. That's definitely not flat.
Perfectly flat, and he.
Not perfectly flat. Not completely flat. There, you can even see it more. You can see the way the sun is shadowing over the curvature there on the top left, right there.
In his book, he puts forward many arguments that show.
Yep, curvature again. Curvature. Not flat. Curvature. I don't know much about this picture. I don't know much about this city. That could be a mirage. It could be a city that's close enough to be seen, and that fuzziness and stuff is just due to pollution. I don't really know enough about the picture, but I know what I can tell you. That ain't flat. If you are seeing that as flat, then I understand why we see the world differently, because that does not look flat to me. Just putting it out there, just saying it. That does not look flat.
Many experiments that show the Earth is always perfectly.
Not perfectly flat. Not in any sense of the word.
Flat. They say that you see the masts.
Okay, so this guy's about to say, well, they say you see the masts going down into, first the hull goes, then the mast, and blah, blah, blah. All right, well, we're going to see. We're going to see videos right here. I'm still calling curvature. Curvature. Absolutely. Over the next several scenes, we're going to see boats disappear over the curved horizon, just as the scientists say, from the bottom up. And the beautiful thing is, we're going to see it
go down last. It's literally just the way your vision works. It's perspective.
Yeah, it's not just perspective.
And atmospherics, basically.
Okay, look, watch. Up. Is that ship disappearing from the bottom up? I'm just wondering, because it looks like it is. Really looks like it is. All right, so. Okay, so. Atmospheric refraction is the deviation of light or other electromagnetic wave from a straight line as it passes through the atmosphere due to the variation in air density as a function of height. This refraction is due to the velocity of light through air decreasing with increased density. Atmospheric refraction near the ground produces mirages and can make distant objects appear to shimmer or ripple, be elevated or lowered, stretched or shortened, with no mirage involved. The term also applies to the refraction of sound. Atmospheric refraction is considered in measuring the position of both astronomical and terrestrial objects. So, and then down here in the second paragraph, terrestrial refraction usually causes terrestrial objects to appear higher than they really are. Although in the afternoon when the air near the ground is heated, the rays can curve upward, making objects appear lower than they really are. So, astronomers, geographers, cartographers, surveyors all take atmospheric refraction into account when astronomers measure stars or other celestial objects, and when these other folks measure terrestrial objects. So atmospheric refraction is very real. So one of the cool things about this video, or one of the funny things I should say, is how we segue straight from this guy in the interview kind of laughing about the idea that atmospheric refraction can cause weird things and can cause anomalies when you're trying to view objects. We go straight into perfect footage, just perfect example footage of boats disappearing over the curved horizon exactly as predicted by science from the bottom up. It's a beautiful thing. Now watch this closely. Oh yeah, look at that boat disappear, baby.
The limit of your vision
Bottom up.
is supposedly 3 miles.
Excellent.
And then after 3 miles, you're supposed to see
Oh, and
the boat
curvature.
start to go over the horizon. It's funny that Neil deGrasse Tyson again says that explains that you can't see the curvature of the Earth from a plane.
Curvature. I'm calling curvature on both those pictures, and both were great examples of ships disappearing from the bottom up as they as you pull back from them with a zoom. So here's the deal with the zoom. All you folks who believe these little flat Earth experiments that zoom in on things and then you can see them again, well, and notice the extreme right here. Notice how the sky and the water have kind of blended themselves together to be the same color. That's a prime example of why airplanes need gyroscopes and artificial horizons from episode 1. Pilot can't tell the difference. Without a gyroscope and artificial horizon, could fly the plane right into the water. Can't thank Odd TV enough again for all this footage. This is just a great picture of curved Earth right here. Every picture you guys use and every flat Earth video is great.
He says this, you can't see the curvature of the Earth from a plane.
Boat disappears.
Because you're not high enough. The Earth
from the bottom up.
Is so big.
Just like the scientists said. Couple interesting things to note. The boat's going to disappear from the bottom up, from the hull up to the mast, and some questions to ask yourself might be
that you can't get high enough to see the curvature, yet you can
hull is almost gone, about halfway.
Apparently see a
hull is entirely gone, working our way up the mast. And where is the boat going if the Earth is flat? You can still see the mountains. It's weird. It's almost like the boat's sitting in a little depression there caused by some vast curvature. That's just weird to me. Very strange.
Boats go over the curvature, over the distance of 3 miles, which doesn't make sense. The thing is,
atmospheric effect caused by difference in air temperature and density. Air temperature and density over land versus air temperature and density over water. Or the boat is magic.
Look out and you see a boat start to go over the horizon.
Amazing footage. Just awesome.
If you suddenly get a pair of binoculars and look, it comes back again. And
so we know that binoculars or zoom functions on cameras only change the apparent distance to the object that you're viewing. Doesn't keep the object from disappearing in the end. And again, if the Earth was flat, these things wouldn't be disappearing at all. They would remain in constant view no matter how far away they were, especially on the water, up to hundreds or even thousands of miles away, depending on how big the object was.
Sight of your binoculars, if you get a telescope, it comes back again. It doesn't go over any curve of the.
Now, before we watch another boat disappear over the curved horizon, I'm not fooled by this zooming in and out thing, and neither should you be. Curved surface of Earth curves gently upward and away to the horizon where the buoy and the boat are, and then downward and away after that, the point you can't see. Let's watch.
Horizon. What we found, many people have done experiments.
Okay, boat and buoy already in the process of disappearing over the curved horizon. There's the top of the boat's hull. The buoy is almost already
with very high,
completely invisible, and now there's just the barest hint of the boat's hull that can be seen if you look in closely.
Powered zoom.
And now notice something about this picture. Notice how it's tilted. Notice how it's obvious that the camera is tilted such that the water on the right is higher than the water on the left. The camera is going to continue to pan back, and as it does, there's going to be some land that comes into view on the left. And the way they have the camera angled, it appears to make the land roughly the same height as the edge of the water on the right. But as it continues to pan back,
cameras, and they've.
Now, the curvature of the Earth is the curvature of this water. The fact that there's a landmass sticking out of it, I mean, yeah, technically that's a terrain feature, but the true curvature of the Earth can always be seen in the water.
Watched a boat sail out to sea, and they've just kept trained on this boat. And what they see is, after a very long distance, you see an atmospheric effect where the bottom of the boat disappears.
Hold on now, back the truck up. I thought atmospheric effects were just NASA lies to fool us about the shape of the Earth. Turns out it's pretty handy when you want to explain why things don't look the way they should if the Earth really was flat. I'm just saying. I tell you, friends and neighbors, this guy's starting to peg the BS needle.
And starts, and the top of the boat inverts, so you see a sort of mirror image. And that...
Okay, now this is maybe the least desirable hand gesture he could be using. Watch the body language of the other guy, the one on the left in the next scene. He makes an involuntary warding gesture with his left hand. His right hand is shaking like he all of a sudden got palsy. Not good. He's terrified.
With your eyesight, basically the bottom of the boat just melts into the horizon. One of the best examples of that is the Antwerp Notre Dame spire, which can be seen something like 240 kilometres away from, from the spire. So that should be over a mile below the horizon, and you can still see it.
We're going to go over a few notable anomalies in the next few minutes of this video.
There's been a few famous examples.
And why are there only a few famous examples, sir? Could it be that there are only a few places on Earth where terrain features and atmospheric conditions combine to make these kind of things happen? Huh. I wonder.
Just recently, of a man who took a picture across the Great Lakes from Michigan and was able to see, I believe it's Chicago.
This was noteworthy precisely because it doesn't happen all the time. You usually can't see Chicago across the Great Lakes.
Which he shouldn't have been able to see. And
what he means to say is that you normally can't see Chicago across the Great Lakes unless atmospheric conditions and lighting and everything combine to give you not only a great view of the Chicago skyline, but even details like lights. It's amazing. So we're about to watch some footage of a news report, a local news station either in the Great Lakes area or Chicago area, reporting on a picture captured by a photographer named, I believe, Joshua Nowicki, and describing that it's a mirage. And I would just ask everybody to remember that if it was normal to see Chicago across the Great Lakes, there would be, first of all, a ton of pictures of Chicago as seen across the Great Lakes, and B, it wouldn't be on the news because it wouldn't be unusual. This is an atmospheric condition that doesn't happen all that often, and especially doesn't produce a perfect image like this. It's truly rare and amazing.
Yeah, and the television station basically said it was a mirage.
This is from Joshua Nowicki, and what you're seeing here is a mirage.
It's amazing,
we typically
really.
would not be able to see this from the Lake Michigan shore. We talked about this last night.
You can see details on the buildings. You can see lights. It's really a perfect mirage, a perfect example of atmospheric refraction. Absolutely perfect and amazing. So what D. Murphy 25 is about to argue is that mirages or atmospheric refraction are a terrible reason to explain why you can occasionally see Chicago across the Great Lakes, but they're a fabulous reason to explain why ships disappear over the horizon on what should be a flat Earth. And this is why I have to believe, at least a little, that all these guys are con men, just hustlers, charlatans, because they try to say first that these explanations are lies to keep the true shape of the Earth hidden. And then they try to use the exact same science that they've just said is BS, basically, to prove that the world is flat. They do the same thing with pictures. It's amazing.
Conditions are right on the lake that we're actually seeing a mirage of the Chicago skyline.
But they always say it's a mirage, but for a mirage...
Ha! Mirages, say the lying round Earth scientists. But let me tell you why ships disappear below the curved horizon. You know why that is? Mirages. Get it right.
To happen, you have to have very specific atmospheric conditions. And there have been so many people who've seen exactly the same thing on different days, different seasons.
Well, we know Mr. Nowicki saw it and took a picture of it, and everybody who saw the news program also saw it. I think the Epic of Gilgamesh is the oldest book in existence, like 3,600 years old. So we've been writing stuff down for a while. Do you have any specific people or dates or seasons or events, any records whatsoever to offer?
Always the same. It's not a mirage. It's simply that you
need to ignore science and your eyes.
You're looking across a plane.
The spherical surface. And this should be a meme. With his right hand, he's indicating how far above his head his own BS has risen, and with his left, he's making the universal gesture for give me some cash. The grin has become plaintive, almost like he knows how bad the scam is, but he also knows that for whatever reason, a few folks out there will fall for it and will give him that sweet, sweet cash.
See in a kind of pyramid shape. Yeah, you have a horizon at your eye level, and everything above the horizon will go down into the horizon. Yeah, everything below the horizon will seem to go up.
So when Flat Earth wants to provide an image of a flat surface, it's always either a drawing or a picture taken inside a building. And the reason is that getting good outdoors pictures of Flat Earth when you're stuck here on round Earth is very, very difficult. In fact, the spherical nature of Earth makes it nigh impossible to prove she's flat.
Like if you're in a long hallway, you'll see that the walls will start to move in, and the roof and the floor will start.
And right on cue, picture taken inside a building. Now first, the walls, floor, and ceiling only appear to close in toward the end of the hallway. They don't actually close in, and this is just a demonstration of perspective. The problem I have with this particular picture is the camera's focused at a spot on the floor down the hallway, which makes the floor appear to rise more than it would if you were just in the hallway and staring naturally at pictures on the wall and other things that were at eye level. But moreover, it does nothing to prove any specific shape of the Earth. It just goes to show that if you're looking at a drawing or an interior man-made surface or the naturally curved exterior of the planet, the horizon will appear to rise toward eye level in the distance.
Start to move into the center. Yeah, so literally between you and the object you're looking at, there's all sorts of things, sort of like waves going up and down, and while you can't see them if they're beyond the limit of your sight, sometimes they can still obscure what you're looking at.
Okay, so I guess this means we've accepted atmospheric refraction as real, but let's just sum up what we've learned in this video. First, when it was properly performed, the Bedford Level experiment confirmed the curvature of round Earth. Second, all the video clips and pictures in this video so far have confirmed that objects on the water disappear from the bottom up, just as predicted on round Earth. So far, I have to tell y'all, it's not looking so great for flat Earth. Looking kind of lame.
But it's just because they're between you and it, and it's just the way. It's literally perspective. It's better if I could draw a diagram, but it's a very difficult subject to get your head around if you're not used to it.
And speaking of difficult to get your head around, let's wrap this video up with some conclusions. One is that the Flat Earth video strategy seems to be to pack as much garbage and nonsense into roughly an hour as possible. Then it takes 5 times as long to unpack it all, explain it all, and point out the fallacies. Another is that this guy, just like the Eric Dubé video, tends to blend in just a bit of science, although this guy clearly doesn't have the scientific knowledge that Dubé does. But the end result is the same. Their arguments, their assertions, they just don't hold up, and they have no bearing on reality here on Earth, which, incidentally, is round. Now, if you stuck with me throughout the course of this entire video, I want to thank you for your patience. If you liked it, please leave us a like. If not, give us the thumbs down. If you want to support the effort against science denial in all its forms, first and foremost the Flat Earth movement, please consider subscribing. And until we talk to each other again, be good to yourselves and each other. I have been your humble narrator, the Madman. Peace out.